if it happens this way, at t less than 0, then at t equal to 0, the lever goes up. At t less than 0, that means it goes down, it's down. So it's connecting between point A and B. Okay, at t larger than 0, that means there's an open circuit between point A and point B. So open circuit at t larger than 0, short circuit at t less than 0. Okay? Is that clear? Any issue on the switch? If you have this switch, that means looking at the arrow, the direction of the movement of the lever of the switch, that means it goes up, the switch goes up, and following this direction at t is equal to 0. So, meaning to say that less than 0, the lever is down here, connecting point A and B, and therefore short-circuiting A and B. Okay, that means there's a connection between this 6 ampere source with the whole circuit, with the whole circuit. Now, if t larger than 0, the switch goes up and stays up. Therefore, disconnecting point A and B, and therefore there's an open circuit between A and B. If this is point A and this is point B. Yeah? So disconnecting point A and B, and therefore disconnecting the 6 ampere source with this part of the circuit. So now you are asked to determine what is I, I0, and V0 for all t. So for the most important equation in the source-free RF circuit is your IT is equal to I0 exponential minus t over tau. Right? So first we want to determine I0. To determine I0, we should analyze the circuit for what? T for t less or more than 0 to determine I0. Yes, because I0, what is I0? I0 is the same as I at time t0. And from the first part, yeah, from what Prof. Ashidi has taught you is that the current that flows through the inductor cannot change abruptly. So that means I at time 0 minus is equals to I at time 0 is equals to I at time 0 plus. Meaning just before the change happens, the current is the same as the current at time 0 and is the same as the current at I just after the change happens, I 0 plus. Okay, so to determine this I0, that is the I at time 0, that means we must look at the circuit when t is less than 0. So when t is less than 0, what happens? The lever of the switch here is down, isn't it? Connecting the 6 ampere with the rest of the circuit. So with t less than 0, the circuit looks like this. There's a short circuit here. The switch is down at t less than 0. And therefore you have here 4 ohms. You have inductor 1 Henry, and you have the resistor 3 ohms. Okay. Right, so this is I0, this is I, and this is the V0. Okay. So after a long time, that means this inductor here behaves like a short circuit, isn't it? Because we want to look at the circuit here, we want to know what is the current through the inductor just before t is equal to 0. So that means it has been supplied by this ampere but for a long time. Yeah? So for a long time, this 1 Henry will behave like a short circuit. So then, yeah, you can replace the inductor by a short circuit. Okay. This 4 ohms, this is I0, this is I, and you have a resistor 3 ohms here. And you have 2 ohms here, and this is your V0. Okay. Now, you can see here that this 3 ohms and this is a short circuit, right? So they are in parallel. What is the total, the equivalent resistance?
0.
If you have a 3 ohm here and you have a short circuit at this point, right? So the 3 ohms is in parallel with a 0 ohm. Is that correct? So the equivalent resistance is 3 times 0 over 3 plus 0, isn't it? It's 0 ohms. So these 3 ohms and parallel with the short circuit can be replaced. 6 ampere. In the analysis, can be replaced by just this. This is 4 ohms. This is I naught. Okay, this is I. And this is the 2 ohms. This is mu. Okay.
Macam mana dia boleh alihkan tu ah?
Okay, so what is the current that we need to know to determine I naught? Is I at time 0. What is I naught? I naught is I at time 0, and what is I? I is the current that flows through the inductor, right? So what current are you finding out now? Is it I or I0? I or I0? You want to find this I or this I? I or I0? Huh? This is the current that flows through 4 ohms, right? This expression is for the current that flows through inductor, isn't it? And therefore this I naught is the current that flows through inductor at time 0. Is that true? So is it I naught or I we are trying to find?
I naught.
Alright. We are trying to find I, not this I naught. This question is purposely putting you I naught here, so that you might be mistaken with this I naught here, right? But it has to be in your mind. You have to really understand that this equation is actually current flowing through inductor. So when you want to find the I naught here, which is this I naught here, it is actually the current that flows through the inductor at time 0. And this is this current, isn't it? Because this I is the current that flows through inductor, and this is the current that you need to find. This is the one that is equal to this I naught here. Can you see that? Don't be mistaken, yeah? The problem here is trying to make you, if you can solve this problem, that means you'll be clear on what type of current that you need to find, yeah, to determine. So this equation is for the current that flows through inductor. So this I naught is actually the current that flows through inductor at time 0, and therefore in this circuit it is the I that you need to find at time 0. So the I naught in this equation is actually this current at time 0. So this one at time 0. Okay? So what is I? So what is I? Using what theorem? Current division. Using current division. So the I at time 0 is equal to this resistor, 4 ohms, over total resistance, 6 ohms, times the current source, 6. 4 ampere. Okay? So that's your I naught. And the question says, determine I naught and V naught for all t. For all t, that means including for t less than 0. So what is I
0.
naught less than 0? For
0.
So this circuit is for t less than 0. What is I naught?
0. 0.
Using current division also, isn't it? So the I naught here is 2 over total 6 times 6. 2 ampere. Right? And what is V naught?
Hey, that's okay.
What is V naught? Using what? Using Ohm's law, isn't it? Voltage is current times resistance, right? So V naught is I at time 0 times 2. So it becomes 2 times 4. 8 volts. So is that clear? Yeah, so for t less than 0, we see that the switch is closed and therefore connecting the 6 ampere with the circuit on the right here. Therefore the circuit looks like this. And after a long time, just before t is equal to 0, that means the inductor is behaving like a short circuit to a DC signal. And therefore it can be drawn as a or symbolized by a short circuit here. Then you find that these 3 ohms and the short circuit is in parallel, therefore making it an equivalent resistance of a short circuit. And therefore the circuit looks like this now, with the current flowing to inductor here, and also you have 2 ohms, the voltage across 2 ohms is V0, and the current that flows to the 4 ohms is the I0. And these are the I0 at times for the circuit less than t less than 0, I for the circuit t less than 0, and V0 for the circuit t less than 0. Those are the values. Now the second thing, because we need to find all these parameter variables for t larger than 0 also. So for t larger than 0 is this equation over here. Okay? And you need to determine also the tau. I0, you know that this is the current flowing through the inductor at time 0, so it will be the same as this I at time 0, 4 ampere. Yeah? So here I0 is equal to 4 ampere. Yeah? And this is to be used as the initial current that flows to the inductor for the circuit at t larger than 0. Okay, so I0 is 4.